Welcome back to this video series of C++ programming. This is the lecture 14 of this video series, and today we are going to talk about pointer to class members in C++. Pointer to class members are very rarely used, but since they are part of C++ programming, we will understand them in this video lecture. So let's get started. Let's talk about some of the important points about pointer to class members. First, C++ allows you to generate a special type of pointer that points to generically to a member of class, not to a specific instance of that member in an object. So it's a one special type of pointer. It's not like a normal pointer, and it's a generic pointer that points to a member of a class, but not to specific instance of that member or the data member in an object. We'll talk about this point when we see an example. This sort of pointer is called pointer to class member or pointer to member. The third point, a pointer to member is not same as normal C++ pointer as we talked in point 1. Instead, a pointer to member provides only an offset into an object of the member class at which that member can be found. So that address is just an offset where that member can be found in a class. And that address is then pointed to that member or pointer variable. And since member pointers are not true pointers, the dot and arrow operators cannot be applied on them. To access member of class given a pointer to it, you must use the special pointer to a member operators, and which are this dot asterisk and arrow asterisk operators. At the first place, this point looks quite confusing. So we'll understand this all the points with the help of an example. We'll see how we can create a pointers to a class members. First, I will create one class and I will call this as my class. Inside this, I will create some private data members, or rather I will create some public members. Inside this class, I have created two public members, which are data1 and data2, and one member function, which is printing the value of data2. And now inside this main function, I'll create an object of this my class. I'll call this as object. Now with this object we can access all the members of this class. So since all the members are public, we can access directly them using this object. Now if you want to access this members with the help of a normal pointer, how we can do that? So first we'll see how we can use a normal pointer. So now since this data1 and data2 is of a integer type, we have to create the pointer which is of integer type, and I will call this as a p. And then with the help of an object, we'll assign the address of this member variable data1. So now this p, which is a pointer, is holding the address of this data member data1. And with the by dereferencing this pointer variable p, we can print the value of this data1 variable. So this is the normal C++ pointer. So p is a normal C++ pointer, and it is a true pointer. Pointer to class member are created in different ways, so their syntax is different. So let's see how the pointer to class members are created. Here the integer is a type, and after this type you have to specify the class name followed with this scope resolution operator and then asterisk sign and then the name of that pointer variable. So now this becomes a pointer to class member. So if you compare with this a normal pointer, you can see that some difference here. So here you need to include the class name and then the scope resolution operator and then this asterisk p. And here we can initialize this pointer variable by assigning the address of this member variable. So unlike this normal pointer, how we can assign the address is you have to specify this ampersand operator, the name of that class, the scope resolution operator, and then the member variable. So if you compare this statement and this statement, the only difference is this class name and a scope resolution operator. So this address is just an offset to this particular member in a class, and with this offset value will able to compiler will able to know where is this variable is present. And now with this pointer variable we can dereference this data1 variable, or we can modify this data1 member variable. So if you want to print the value of this data1 variable using this pointer variable p, that is dereferencing, then how we can use the dereferencing in this pointer to class member is you have to specify the name of object, in this case object, then dot operator, and then asterisk p. So now you have to use this object and then dot operator to access this pointer to class member variable. So now you can see the difference between these two statements. This is one is the normal pointer and another is the pointer to a class member. So I will delete this code here, and here we'll initialize the data1 variable to some value. So now let's compile the program and let's see whether it is printing this output value as 40. And you can see now it is printing the value as 40. So this is how pointer to class members are created and used. Similar to this, we can create a pointer to a class, a member functions. So this is a pointer to a data member. Similarly, we can create a pointer to a member function. So let's see how we can create that. Now in this case, we have created this member function called as a display data, which is returning a void, which is of a void type, and it doesn't take any arguments. So here we'll create one pointer that will point to this display data function. So how to create that? Now this return type of this function is void, so this pointer variable must be of a void type. So here you have to specify the type, then the name of class, scope resolution operator, and asterisk sign, and this is a pf. This is the name of this variable that will hold the address of this function. So this is now acting as a pointer to a member function. We'll assign the address of this function to this pointer variable. So how to do that is you have to specify this address, then the name of this class, scope resolution operator, and then the name of this function. Similar to assigning the address of member variable, we can assign the address of any function to a pointer variable, which is actually a pointer to that member function. And now with this and using this pf, we can access we can invoke this display data function. So how to do that is similarly, like we have to specify the name of object, and then this asterisk sign, and then this pf, and then this. So since this is a function calling, we have to specify these two brackets here. So we're not returning anything, so we just invoke this function here, and it will print the data2 value here in this function. So here we'll initialize this data2 member variable to some value. So now let's compile the program and let's see what does it outputs. So it is outputting the value as a 40 and 50. So the one is for data1 and another is for the data2. So we saw how we can create a pointer to a class member variable and a pointer to a class member function. We saw how we can use those pointer variables. Here we are using these pointers with objects. So how we are accessing this pointer variable is through this object and a dot operator. Similarly, we can create a pointer to this object, and with that object pointer we can access this pointer variable. So to do that, we have to create a object pointer. So call this a p object, and we'll assign the address of this object to this object pointer. And now with this object pointer we can access this pointer variables. So how we can do that? So instead of this dot operator, we have to just use the arrow operator, and here it should be a p object. So now this is like accessing the normal pointer variable, and then the rest of the part remains same. So you can see the difference now. And similarly in this case, since we are using the object pointer, you have to specify this arrow operator. And now once again, let's compile the code and let's see whether it's outputting the same values. Yes, so it is outputting the values as 40 and 50. So we saw with the help of object pointers, we can access this pointer variables, or pointer to class members, or pointer to class member function variables. This pointer to member functions are very rarely used in the C++ programming, as we talked at the start of this video lecture. So we'll see one example where we can use this pointer to a class members. So I will delete this code. Here I have created one class that contains the two data members, the sample1 and sample2, and we'll write a code that will count these samples, number of samples 1 present and number of samples 2 present in the program. For that, we'll create one object for this class. So we'll call this as object, and we'll create array of objects. And inside this, we initialize this array of objects. So when we initialize, we mean to say we are initializing this member variable. So we have two member variables. We'll initialize them. Now this 4 is value assigned to a sample1 and 5 is assigned to a sample2. This is similar to initializing any two-dimensional array. Lecture of constructor, we saw how we can initialize the array of objects. So we created one constructor. So but in this case, these members are public to this class, so they can be accessed outside the class. So here we can initialize them without creating another constructor or another function. So since they are public, they can be directly initialized while we create the object. And we'll create one function that will count the samples. So this it will return the value as an integer, and we'll call this as a count samples. This is not any class member function, so this is just a normal function. Now we'll invoke this function. So for counting this samples, so what we have to do is we have to count this number of samples 1 and number of samples 2. So in this case, number of samples ones will be 4 plus 7, so 11, and samples 2 will be 5 plus 8, that is 13, right? Now we have to pass some parameters for counting. So here I will pass some parameters. First I will write a function, then we'll understand how it is working. So here I will pass the base address of object, then the object address offsetted by 2. So now this object will be pointing to this memory location, and object plus which is opposite of 2, so it will point to the next object. So this it will point to object and object of 1. And here I will pass the address for this sample1 data member. So here to collect this arguments, we have to create the proper data types. Now this is object of a type my class, so we have to create a my class, and since we are passing the pointer, we have to specify the pointer. So I will call this as a start. So this is the starting point. Similarly, I will create another variable which is now ending point, and now we are passing the address. This is a address of a member, address of a member variable, and since we are using this, and so we must collect this as a pointer to that class member variable. So how to do that? So this is of integer type, so I have to specify the type, and then the name of class, in this case my class, scope resolution operator, and then asterisk sign, and then this variable. So now this p will collect the address of this data member variable. Here I'll create one loop. I'll create another object inside this, or rather object pointer, call this as iteration, and it will point to the start address of this object, and we'll check condition is not equal to end, and then we increment this object pointer, and then the for count will add the count for each sample. So now here we have collected this into a pointer to a class member. So now with this pointer to class member, we can call the respective, we can take the value of a respective data member variable. So how we can use is we have to specify the object here, this, object name, the dot operator, and then the asterisk sign, and then the name of that pointer variable. But in this case, now this iteration is a object pointer, so it's not object, so we have to use this arrow operator. So now when we are passing this address of the sample variable, this count will count the number of values for this sample1 variable from this object. So we're iterating the loop for this offset value of 2. So till the end we are iterating this loop. Similarly, I will add another statement that will count the number of sample tools. So now let's compile a program and let's run it to see whether it is outputting the sample values correctly or not. So you can see now it is outputting the sample 1 as 11 and sample 2 value as 13. So let's verify. So 11 is 4 plus 7 and 13 is 8 plus 5, that is. So it looks correct. So this is how the pointer to a class members can be used. As we talked, they are rarely used, but they can be used in some tricky problems to solve the tricky problems. So in this case, there are multiple ways to count the number of samples, but this is one of the way. So what we achieved in this by using this pointer to class members, we don't have to call uh, the the function that will count the samples for sample1 variable and another function that will count the samples for sample2 variables. So using only one function, we counted the samples for both this data member sample1 and sample2. So I hope now you have understood the concepts of pointer to a class members in C++ programming. So for now, thanks for watching this video and stay tuned for the upcoming videos.